All right, guys, I have got an absolutely massive week this week in every measurable way. Massive week of blog traffic, massive week of announcements and things happening, and just like lots of other stuff that I thought was particularly interesting. So where I actually want to start is something kind of unrelated to most of the stuff I've written and done this week, but this is sort of on the interesting front. I saw a story just the other day about credential stuffing. And in fact, there's one really, really interesting part of this. Now, keep in mind that credential stuffing is attacker gets a whole bunch of usernames and passwords, and then they try them on your system. So imagine they've gone and gotten some of these big combo lists, which have got just about everyone's email address in there. Certainly my email address is in many of these, as well as a bunch of passwords they've used in previous systems. And then they go to your site and they try to log onto your site with those credentials. And of course, it's highly automated as well. But here's the interesting thing. There was a story here about the FTC sending a bit of a message about credential stuffing. Here's the quote. The FTC's message is loud and clear. If customer data was put at risk by credential stuffing, then being the innocent corporate victim is no defense to an enforcement case. And I was a bit taken aback, if I'm honest, when I first saw this, because what this is saying is that if someone comes to your site and logs on with a legitimate username and password, then it's no defense that the credentials were correct. They were owned by an attacker, by some adversary trying to compromise the person. And the reason why I was a bit taken aback is it's like, well, this is actually a hard problem for corporations to solve. Now, the FTC then goes on here, or the story goes on and says, well, look, we should have multi-factor authentication, for example, which of course we should. It's a very, very good thing to have. Then, of course, there are other mechanisms of defending against credential stuffing. There are certainly people that use Have I Been Pwned to see if email addresses are at high risk. There's the Pwned passwords we're going to talk about in a moment as well. I just thought it was really interesting to actually see a legal precedent like this. So I think that's going to be particularly interesting as we go forward. Is the new norm that you always have to expect attackers are trying to break in with legitimate credentials? And to be honest, like we should be expecting that anyway, but to actually see the FTC saying it's no defense, it's like, wow, that's actually kind of hard. Okay, so let's move on and talk about Pwned passwords, because I just mentioned that. Now, I'm trying to remember the chronology here. I spoke about Pwned passwords in my weekly update last week, bang on a week ago, and I record this, where are we now? It's about 10 o'clock on Friday morning, my time, in the future in Australia. I released Pwned passwords very early Thursday morning last week. So I'd had like a day and a little bit of Pwned passwords before I recorded this message, before I recorded last week's update. And, you know, stuff had sort of gone pretty big then. It's gone massively bigger since then. And I want to talk about why, and that's going to lead us into other things. And also, yes, I am wearing a Cloudflare t-shirt. I'm going to talk about Cloudflare. I have also packed all my other t-shirts to go away, and I'm looking through the cupboard going, how many free conference t-shirts have I got here? My wife loves it too. When I come home with a free conference t-shirt, she's like, yay. But anyway, I'm going to talk about Cloudflare, so I thought I'd just put the Cloudflare shirt on. All right, so I want to talk about Pwned passwords. Now, there's been loads and loads and loads of good use cases and good feedback about Pwned passwords since I launched them. And if I'm honest, I'm a bit surprised. Not because I don't think it's a good thing, but because like Pwned passwords 1 was here in terms of feedback and coverage and everything, and Pwned passwords 2 is like massively higher. So it's had a huge amount of press. There's been loads of people, everyday consumers coming to the website, checking out Pwned passwords. It's been integrated into lots of things already. So I'm retweeting a lot of organizations or individuals that integrate it into their services. There's a bunch of comments on my Pwned passwords launch page about that, which is really cool. There's 2 in particular I want to call out, and I don't think I had them in last week's video because they weren't done yet, but 2 use cases which I just thought were epic in different ways. One is that 1Password, the password manager, built it into their platform and published it and got it live on their system about 27 hours after I launched Pwned passwords. That's what I did. About 27 hours after I launched Pwned passwords. Now, this was really cool. They had no prior notice. I had not spoken to 1Password at all about what I was doing. And all I knew was on Thursday, someone popped up and said, hey, we're going to integrate this. I thought, wow, that's pretty quick. And on Friday morning, it was done. And basically, the way they've implemented it is that when you're using the 1Password service, the one where you can also log into your password manager online, there's a keyboard shortcut which then enables a little button next to the password where you can say, go and check it and see if it was pwned. Now remember, I did speak about this last week, but the model within Have I Been Pwned, which I'm using most extensively now, and I'm going to talk about how extensively. And let me just clarify, when I say I'm using most extensively, people consuming the API are using most extensively, is the K-anonymity model. So this is the one where you take the plain text password. So this is you guys using the service. You take the plain text password, you SHA-1 hash it, you take just the first 5 characters, you send that to me, and then I come back and go, here's on average 487 hash suffixes, and then you match them up and compare them, and if they match, then you're good to go. And when I say good to go, it's, this matches the hash that you search for, ergo the password in the repository of 500 million of them. So this is what 1Password is using. So I'm not getting full passwords by any stretch of the imagination. I'm getting a part of a hash, and that matches hundreds of different possible results. And there's untold numbers of other results that could possibly hash down to the same first 5 characters anyway. And then I don't log it or do anything like that. So, from their perspective, they're very comfortable with that model. I was really happy to see someone like a password manager actually say, look, we're going to add a feature into our product which sends your password or a representation thereof off to this Aussie guy's service who's like stood it up on cloud storage. So, yeah, I was really stoked to see that. I was also really stoked to see how positive the feedback was. So every single response I got about 1Password doing this was just like, right on, guys, awesome. So cool you've done this straight away. I think they're riding a wave of positive sentiment at the moment as well, which is really good because they do make an awesome product, and I'm very happy to see them getting good feedback for it. I was also happy to see how many people then started saying, all right, LastPass, Dashlane, level up. It's time for you guys to do the same thing. In fact, I saw a lot of people even say, look, I'm going to change Password Manager if you don't do it, which I thought was interesting because that is, that's a big move. I'm not sure that I would actually change Password Manager due to a lack of that functionality, but obviously I'm very happy if people feel it's valuable. So that's awesome. It's had massive traction there. I did a podcast with Patrick Gray on Risky Business, which went out a couple of days ago. I'll link to that in the notes as well. So he and I had a good chat about that. Obviously, the feedback I've had from listeners of that show were very happy with it as well. They said this is cool. And it's just been positive feedback. It's just been really, really nice feedback. Except for these 2 bits. We have discussed before how some people on the internet like to lose their minds. Like, this is pretty much a full-time job, as best I can tell, for some people. And, there's nothing like sitting behind a keyboard somewhere else on the other side of the world to embolden people to tell other people exactly how they feel. I'm going to read you 2 emails I got because this is like part of my therapy to read some of the abusive stuff I get. Now, the first one's not so bad. Second one, let me read the first one. So someone emailed me, and I think I actually had a chat with this guy. I think it's the same guy in the comments on that original blog post when I launched it as well. And he actually came around at the end of it, but I'll explain why. This guy says, please remove this page. There is a lot of security problems in it. You don't know it, and maybe could not understand. And please stop representing yourself as a security researcher. You are not. I know it. You know it. So, okay, that was constructive feedback. The discussion on the blog post, and in fact, here's an interesting thing. And I know I mentioned this last week because I was talking about people just getting really obnoxious and losing their mind over HTTPS. I was talking about the sort of the way, for want of a better term, you conduct yourself online. Some of the comments from this guy on the blog post were pretty aggressive, very, very blunt. And not the sort of thing that anyone has ever said to me face to face, and he probably wouldn't either, because again, you're emboldened when you're behind the keyboard. And effectively, what he was saying was that the risk that you run is that when someone enters a password into a field on a web page, there are still other potential vectors by which that could be obtained. I'm just trying to choose the right words here. Now, actually, let's touch on this first of all, because I want to be really clear about this. There is this page on Have I Been Pwned where you can enter a password and it will see if it's in the database, and it does the k-anonymity thing and all the, anonymizing, etc. And that's good from a privacy standpoint. There is also the argument, which is the argument that I myself made in Pwned Passwords v1, which is asking someone to come to a website, a third-party website, like Have I Been Pwned, and enter their password is not a good sort of conditioning exercise. This is not something we want to get people doing. And I'm the first to say I don't want circumstances where we encourage people to do the wrong thing, because that then leads to them doing the wrong thing in other places. So a really good example is there are financial services out there which say, look, we can plug into your bank account. So go to our financial service, enter your bank account credentials, and then we'll plug into your... That's just a terrible idea, because it's conditioning people to enter credentials for a very important account into some other third party, and then you've got to trust they do the right thing. I don't know what happens if there's fraud there, by the way. That doesn't feel very good. So I'm conscious of the conditioning. In version 1 of Pwned Passwords, I actually had big text there, bold text, just before the search box. And it said something along the lines of, don't enter any real-world passwords you still use. And the sentiment was, maybe you've got a password which you no longer use because you've seen the light and you have improved your password practices. Enter that one, because if it gets obtained by some nefarious purpose, well, then you're all good. People tend to not read instructions. And actually, I find this really funny, right? So this is like one sentence, really, really simple. Loads of people didn't read that. And then you look at things like I've mentioned Experience Dark Web Search. I was going to say it with a lower voice. Experience Dark Web Search, which allows you to enter your email address and go and search stuff. Their terms and conditions total about 27,000 words that you're meant to read before searching it. I can't get people to read one sentence. Good luck reading 27,000 words. So anyway, people don't read stuff. They'll go and enter it anyway. But the thing is, and this is sort of the other side of the argument, loads of people with Pwned Passwords v1 did search for their passwords. And as a result, they changed their behavior. And this is a positive outcome. And when I say change their behavior, they went and got password managers. They stopped reusing the same password. They became conscious that this thing that they treated as a secret that was in their brain was actually already out there. So it drove a very positive change. In V2, being conscious that people are not going to read the damn instructions anyway, and with the K anonymity, I took that little piece of text out. Now, what this bloke is saying is there are a few problems here. Let's run through all the potential problems with Pwned Passwords. One is that whilst you enter that password in plain text onto the Pwned Passwords page, and client-side in JavaScript, it's JavaScript, you can go and look at it, it will hash that password, take the first 5 characters, and only send the first 5. What if I change the implementation? What if I one day decide to just start siphoning off plain text passwords? What if I get compromised and someone manages to change that JavaScript? Remember Browse Loud only a couple of weeks ago? That JavaScript file which was requested in real time off their services, put on thousands of other websites, and they got CryptoMiner in it. What if that happens? And these are all perfectly valid points. If any one of those things happens, people start to get passwords. The other thing here is that, and someone else was making this point, and we did have a little bit of a debate about this, but they did make a good point, and I want to recognize it. They said, even if I just get the first 5 characters of a hash, and I make the argument that it's just the first 5 characters, there are all of these suffixes of hashes that it could belong to, and mathematically it could theoretically be any one of those, and I have 487 on average for each one of those hashes, each one of those prefixes, and there's gazillions of other ones that are not already in the Pwned Passwords database. Law of probability means that I could take that prefix and say your password is probably going to be one of these 487 I've already got. And even within there, it's probably more likely to be this one that's appeared 10,000 times than this one that's only appeared once. And this is a perfectly valid point. This K-anonymity model is not perfect. I could actually use it to get a bit of a sense, a pretty good sense, of which password it's likely to be. Here are the things offsetting that, though, because we've got to remain pragmatic about this. So first of all is I don't log it. I don't store it anywhere. It goes through transient logs which are purged very, very quickly. I can sort of see what's coming into the server and then they're gone before you know it. If someone does manage to compromise have I been pwned, I'm going to have a whole bunch of bigger problems. I really am. It's not going to be a fun time if that ever happens. It's always possible, but it's extremely unlikely. And thirdly, and this one's really, really important, whether you get just the first 5 characters of a hash or the full password in plain text because you compromised the JS and you're just sucking off what's in the field, there's no context to it. It's not like here is the username that belongs next to the password. That is not how it works. All you're doing is you're putting in a string of characters. You don't know which account it belongs to, and probably the furthest you can kind of stretch this argument that this presents a vulnerability is that if you knew the IP address or if you were tracking and you knew who the individual was because you could tie them back to other behavior somewhere else, maybe you could figure out whose password it is and maybe you could then test it against other accounts. Oh, and by the way, the FTC just said you've got to expect people to do that anyway and it's not an excuse. So I want to put that in there because that's just entire pragmatism. But the thing that kills that right away is that if this is your concern, download the freaking hashes. Like this was the entire reason of giving people the hashes. Download them, process them locally. Do your own implementation of it. If you want customers going to your site to check for pwned passwords and you don't want to send me hash prefixes, download them, do them locally. You don't need to give me any attribution. You can stand it up on your own services for absolute single-digit dollars a month. It's a simple thing to do. So people have choices. And this is kind of ultimately the point I was making to this guy just here. Now, I mentioned there are a couple of pieces of feedback that were negative. And let me quantify this for a moment as well. I tweeted earlier this week, I said, whenever I do something, pwned passwords, a blog post, a talk, something like that, I get probably 90% of people going, this is awesome, love it, thank you very much. I get 9% of people that are a bit indifferent, and I get 1% of people not so happy. Now, I want to read you an email I got from the 1%. This has language that if you have children in the car, you might want to just skip past this bit, skip maybe 2 minutes ahead. But I think it's worthwhile sharing this. And I've shared abuse that I've had before, particularly in my Hack Your Career talk. There's language there that's even worse than what I'm going to read you now, because I think this is an important part of the narrative. You know, when I put stuff out there, this is some of the feedback that comes back, and this is the sort of stuff I've got to deal with. All right, ready? You can mute now for probably the next 60 seconds or listen to this. I won't say the person's name. You fucking piece of dog shit. I should test my password on your fucking site to check it out whether it is safe. For which agency you are working for? CIA, Mossad, Mexican Mafia. I'm not making this up. He literally thinks I work for the Mexican Mafia. I hope you fucking piece of shit die in a deadly way. Right. So that was fun. I don't know if I've got to put like a language warning on the video or something now. Tell me if I do and I haven't done it and I'll fix it. That is like literally a piece of feedback I get. So, you know, I'm looking at press releases and 1Password doing this and other people doing awesome stuff and just like absolutely awesome epic feedback everywhere. A few people saying, you know, there's potentially this risk, or constructively, what about you do that? And then I get stuff like that. And, you know, look, frankly, that doesn't worry me at all these days. I get one thing out of the blue like this, I file it away. Sometimes I read them out to friends as we're having beers and we have a bit of a laugh. But that is literally some of the stuff that comes back. So that was fun. Now, I mentioned I wanted to talk about a couple of specific implementations. So there was that one from 1Password, which was really, really cool. The other one that's really cool is the Cloudflare CTO, John Graham Cumming. And I actually caught up with John in London in January. Lovely bloke. Went and saw him and a few other people over in their office in the UK. He wrote a really cool implementation that's very, very simple, but I want to talk about it because it's beautiful in its simplicity. Cloudflare has this model called Cloudflare Workers. And what workers are is they're effectively JavaScript that you can run on the edge. And I'm doing air quotes for the people on the podcast, because When we say on the edge, what it actually means is that Cloudflare will run this code in each of their 122 edge nodes around the world. So remember, Cloudflare is a reverse proxy. So when you request troyhunt.com, haveibeenpwned.com, the pwned passwords path, which is on a different host name, you are connecting to an edge node that is very close to you. Doesn't matter where you are, you've got one that is somewhere close to you, at least compared to going all the way to the actual origin website. So you're connecting there, and then they're sometimes serving stuff from cache. We'll talk about cache more in a moment. They're sometimes blocking the request because it could be malicious or there's a firewall rule blocking the IP. And they're sometimes passing that request all the way onto the origin server, and then there's a response coming back, and then they're sometimes manipulating the traffic to do things like compression or put it in their cache, and then they send it back to you. So when we talk about sort of code on the edge and these worker roles, we're talking about what if we could write code that could handle these requests as they're coming through or modify the responses as they're coming back. And the bit of code which John wrote is he wrote a little bit of code in JavaScript. I'm going to link to it in my notes for this podcast or weekly update, which it would look for a post request. It would identify a password field. If it found a password field, it would take the password, hash it, get the first 5 characters, send it off to the range search in pwned passwords, get the result back, and then add a response header when that response comes back, indicating whether the password had been seen before. Now, in some ways, this is very sort of familiar, very common now, where it's just like, hey, hit the pwned passwords, get the result back. The bit that makes it cool is that you can take just this little bit of code, you can drop it into your Cloudflare worker. You've obviously got to be routing your site through Cloudflare. And then when people log on, register, change their password, so these are the 3 places we normally get passwords in clear text, this just automatically takes it, gets the response, and adds it. So you make no code changes to your system per se, and now you get back this response header. Now, of course, you've got to do something with the response header, so maybe you've got to modify some JavaScript, for example. So maybe you're doing like an async postback to do any sort of authentication, and you modify some JavaScript so that if the password's been pwned, someone gets a little warning window or something like that, which says, hey, your password's appeared in a breach. But it was just such a simple, easily deployable implementation that didn't involve mucking around with code on the application itself that I thought it was really cool. And he's had a bunch of great feedback for that too. So that was really cool. Now, I want to do things a little bit chronologically out of order because I did actually write about a whole bunch of new data breaches, but I want to continue talking about pwned passwords first because I wrote about them after the new data breaches, but it makes sense to continue talking about it now. So I wrote a blog post called I Want to Go Fast, Why Searching Through 500 Million Pwned Passwords is So Quick. As I've built out Have I Been Pwned over the years, anytime I've done something that I think people will find interesting in terms of the way it's implemented, I have gone and blogged about it, spoken about it at conferences, even written courses about it for Pluralsight, or written courses about it for free. So there is a course from several years ago, it's not even a course, it's just a YouTube video, called The World's Greatest Azure Demo. And yes, it's a very self-ingratiating title, but it got viewed gazillions of times. Have a Google for it. It's the old Azure portal, but it sort of runs through all the fundamental premises of using paths within Azure. So anyway, I wanted to write about this as part of the whole transparency thing, but also because people were doing searches and they're saying, this came back in like 15 milliseconds. Is it actually working? Well, yes, it's working. I'm going to explain why. Now, this is one of these things which is an evolution. I have other ideas about how to make this better. So I'll sort of talk a little bit about why speed here is so important, in that if organizations do want to integrate Have I Been Pwned into their app and they want to hit the API rather than sort of download the data offline, it's going to be really important to get them a very, very fast response because this could be a blocking process otherwise. And incidentally, if you do implement this, always assume that that service could go down at some point. It's always possible. It's the same fundamental principle for any other service you plug into. Have aggressive timeouts of it on it, have sort of fallback positions if it doesn't respond in time. And frankly, the fallback position for this is easy. You just don't tell people whether their password was pwned or not. So, yeah, I talk about the reason why that's important. Now, I'm using Azure Functions in order to serve the API. Now Functions is effectively serverless code. So think about the old premise of the evolution of cloud services. So, we used to have the old on-prem stuff. We'd have physical hardware sitting on our premises. I remember going into the data center in my old company, and there's just like racks and racks of machines and fire suppressant systems and server admins and everything. And we started picking that up and putting the machines in the cloud where they became IaaS, infrastructure as a service. And then we said, look, that's great, but we're still managing machines. Let's have PaaS, platform as a service, where you get a website or you get a database server. Let me rephrase it, because you don't really get the server. You get a database, or you get something else where someone else manages that sort of operating system layer and you just get the service. And then we had the whole SaaS model as well. Let's have software as a service. My blog is SaaS. I don't manage the Ghost platform in any way whatsoever. All I can do is effectively interact with the web UI. Now, the premise of serverless is we can say, I just want to run code. I don't even want to have the idea of having a platform as a service. Just take my code and execute it. And in a way, this is what the Cloudflare workers are as well. It's like a serverless implementation. Just go and run my code. So I'm using Azure Functions because by being serverless and by paying for the execution of the code and not having any context of logical machines, it should just scale out infinitely. This is the theory. I haven't had massive traffic yet, like many, many, many millions of people a day, but that'll be interesting to see when we get there. So that's neat. It executes extremely quickly. It's extremely lightweight because all it has to do is just get a request to search a range, then go and pick up the result from the database and send it back. I talk a little bit about the way Azure Functions are priced, and they're priced by a combination of execution time measured in gigabytes seconds and the total number of executions. Now this is good because it's sort of saying you pay for how much you use. And I love this model in general. I really dislike cloud models increasingly where it's like you pay this and you can use anywhere up until there, and then you get to like here and then you got to use another big whack. And for the people listening, I'm sort of showing how you fall over into another tier and suddenly you have one extra request, but you've got to go into the next model and the price increases dramatically. I love the Azure Functions model where it's like you just pay for precisely what you use. Use as little as you want, use as much as you want. And incidentally, you get 400,000 gigabyte seconds and 1 million executions for free each month. When I get to the end of the first month, I'll share the figures on how much my stuff's been executed. So anyway, the point is you pay per execution. Wouldn't it be good if I could have less executions whilst having more traffic? All right, so win-win. So this brings me to Cloudflare Cache. And honestly, like this is where the game is at in terms of making Pwned passwords free. Cloudflare is caching a huge number of the requests to the service. I'm going to give you some live stats now because I've got their charts in front of me. In the last 24 hours, I've had 642,000 requests go to pwnedpasswords.com, api.pwnedpasswords. Well, mostly api.pwnedpasswords.com. There's also a download subdomain where you can actually get those original hashes. So 642,000 requests. 386,000 of them have been cached. Now, what this means is that more than half my requests to Pwned passwords have been served from cache. In fact, down the bottom of this page, Cloudflare tells me over the last month, which sort of goes back into, well, actually, it doesn't go back into Pwned passwords v1 because that was on a different domain. It goes back before I was hosting the API on Cloudflare and I was just hosting the hash files, the downloadable hash files. Bottom line is, it says there are 53% of the requests have been served from cache. So when we talk about the Azure functions, I'm going to talk about how I made them faster in a moment. The best possible thing I can do with Azure functions is not have to call them. You know, as much as I like Azure functions, if I can actually respond from one of those 122 edge nodes supported by these guys, then I can make those requests super fast because they can come back immediately. And that's where people are seeing like 15 millisecond response times from. 15 milliseconds from saying, please get me the hash range for blah, and then getting 487 results on average back in the response. So that's cool. I'm getting a huge amount of stuff that is coming from cache there, which is really nice. So the challenge now is I would like to get that up as close to 100% as possible. Because when you think about it, we have got 16 to the power of 5 different possible hash ranges we can search by, because there are 5 positions, I only take the first 5 characters, and we've got 0 through F. I had to think of that for a moment. 0 through F for each one of those values. Now 16 to the power of 5 is 1,000,000 and a bit. If I could get 1,000,000 and a bit API responses cached in Cloudflare, then every time you made a request, you would get that response, bang, just like that, the 15 millisecond kind of time, if you're close enough to a Cloudflare edge node. Plus, they wouldn't hit my Azure function and I wouldn't be paying for the executions. Everybody wins. I'm going to keep working on that. There are some idiosyncrasies around things like cache eviction. Now, there's not much that I myself can do, but I am talking to Cloudflare every single day at the moment. And I'm going to go and see them in San Fran as well in a couple of weeks, which I'm pretty excited about. So I would really, really like to try and get that up. And as I've been saying to them, this is like a massive value proposition for Cloudflare as well, because the more stuff they send from their edge node, the less stuff goes to the origin, the less infrastructure people need to actually handle those requests, the faster responses customers get. This is actually a really valuable part of the product. So anyway, when I make big gains on that, which I hope I will, I'll let you know. Now, for the requests that do have to go all the way through and hit the origin, my original implementation with Pwned Passwords v2 was that I used table storage. In fact, v1 I used table storage as well. v2, I used table storage again, except I created a whole new table. And what I did is I partitioned into petitions and rows based on the first 5 characters of the hash and the suffix. So here's how it works. And we'll take a step back. When you use Azure table storage, you have petitions. You have a petition key, and then within the petition you have rows and you have row keys. And all this is within one table. You can have many, many, many tables in one storage account too. So my first go at Pwned Passwords v2 was that I had a different petition for every single one of the 5 character hash prefixes. So that's 1,000,000 and a bit petitions. So there would be a petition that is 00000. And then within there would be, on average, 487 different rows. And each one of those rows would have a row key, which is the suffix, so the other 35 characters of the SHA-1 hash. And my rationale there was that if you search by individual hash, I can take that hash, get the first 5 characters, say this is the petition, the remainder is the row, go and get me the data. If you do a range search, then I can just say take the first 5 characters and just bring me back the entire petition. This is going to be the fastest possible way of doing it. Now, it was fast, but I thought we could do it better, because as I started thinking about it, I went, well, people are basically just doing range searches. I'll come back to this in a moment. And if they're basically just doing range searches, why do I even need to have a table storage construct at all? Why do I even need to have any sort of formal storage mechanism? Like, why don't I just chuck it all in the file system? So what I end up doing is taking those 1,000,000 and a bit different 5 character prefixes of the hashes and creating individual text files. So there is a file which is 00000.txt, and it sits in Azure Blob Storage. And then there's 1,000,000 and a bit other files. So what I started doing then is saying, okay, well now when you come and you query for a range using the hash prefix, rather than going to table storage and querying table storage, I'll just pick up the file from Blob. I wasn't sure how much difference it was going to make. So I actually pushed the code out with a feature toggle, so I could just go into config and change one to the other, so I can still do table and blob. But I want to share the results that I got here. So what I was getting before, and I've got some really neat App Insight charts here in this blog post as well. I love these charts, they're very cool charts. So what these charts say is that for my original range get function, so there's a range get, which is the range thing, and there's a password get, which takes a full hash. My original range get function on average was executing in 122 milliseconds. Now this is over 403,000 requests in a 24-hour period, so that's a pretty good sample size. 122 milliseconds. The distribution of duration times was a very sort of typical bell curve, like that. And what I was finding is that the 50th percentile was 100 milliseconds. So whilst my average was 122 milliseconds, 50% of the requests were executing in under 50 milliseconds. Function execution time. Now remember also, I told you just before that the way the function pricing works is that you pay based on the duration of execution. So if I could make this less, if I could make it half, for example, I'm going to pay half as much, at least for execution time. It's still the same number of executions, so there's always that factor in the pricing. But when it does execute, it's going to spend half the time executing. Plus, people get responses faster, which is nice. I managed to get it down by just going direct to the blob down to 54.2 milliseconds. And there's 24 hours worth of data there, 308,000 records, still a very good spread. So remember, keeping in mind the original average was 122. I went from 122 down to 54.2, which is a 50% reduction in execution time. Awesome, very happy with that. We look at the distribution. The distribution has the 50th percentile at 46 milliseconds. So we're more than 50% reduction of the distribution as well. So we used to have half the requests would execute in 100 milliseconds or less. Now we've got half the requests executing in 46 milliseconds or less. It's a non-linear distribution though. So table storage was very consistently a nice bell curve. This one has a big peak at 10 milliseconds and then it goes down, and then we've got a bit of a bell curve going over the rest of it. And this looks to be related to the way some content is caching in the function when it pulls it back from blob storage, as best I can tell. If someone from Azure knows better than me, please let me know. All right, so that's really cool. That made a big difference. One thing I think I can do better here is the way I read the stream of that blob and the way I then return that in the function. So I'm going to have a bit of a play with some code. I'd like to think today. I think in reality it's probably not going to happen today, but I'm going to do my best. Now, so that was that. Here's the other thing. Cloudflare has a feature called Argo. Now, Argo is particularly cool, and it works like this. We know, and incidentally, there's like an animated GIF of this on the blog. We know that when we make a request, say from where I am here in Australia, over to, let's say, somewhere in the US, into the US data center, and whether I route it through Cloudflare or whether I just hit the origin site, it's going to go through different nodes along the way. It's going to hop through different places. Do a trace route, you'll see this. Now, there's an interesting question here, which is, what is the optimal path? So which way should it go? So for example, should it go from where I am here in the Gold Coast up to Brisbane, and then maybe across to Hawaii, and then maybe LA, and then, and it hops over that way? Or are there times where it would actually be more efficient to go up through Japan and then across to, let's say, Vancouver, and then down to the West US data center where Pwned Passwords is actually based? Now, what Argo does is it's a Cloudflare implementation that can actually look at things like congested network paths and unreliable connections. Cloudflare routes more than 10% of all HTTP and HTTPS internet traffic. So think about that. These guys are driving like 10% of the internet. Because of that, they've got enormous visibility into where there is congestion, where things are going fast, where things are going slow. And what Argo does is it says, we're going to route you around the most efficient path, because it's not necessarily a straight line. Now think about, for those of us building web apps and not actually living at like critical tier 1 network level infrastructure land. If we're building a website, we've got no control over the route that someone's traffic takes. So let's actually talk about numbers, because this is the important thing, right? Like, it sounds good in theory. What does it mean? With Argo turned on, let's do it the other way. With Argo not turned on, average response time without Argo, and this is over a 48-hour period, the average response time was 706 milliseconds. Now, given that I was just talking about getting responses, even with the old table storage model, getting them in like 122 milliseconds, 706 seems high. We do have the speed of light and distance to deal with because this is a globally distributed audience all hitting one service hosted in one location. And Australia is kind of the other side of the world. Turns out Europe is also the other side of the world to Seattle, where the West US data center is hosting my actual origin website. So that 706 milliseconds is significant. Average response time with Argo for the last 48 hours is only 278 milliseconds. That's more than 60% of the latency shaved off. Now that doesn't change my cost at all. The function's still executing in the same time. I'm only getting this gain because it is actually going to the origin website from Cloudflare's edges. But people are getting responses on average here in 400 something plus milliseconds quicker than what they would be before, and that makes me very, very happy. Also makes me happy because the way I enabled it is I hit the button which said turn Argo on. Now this is something they make available in their commercial plans as well. So for example, I don't get this on troyhunt.com because it runs on the free plan. They're supporting me with the fancier plans for Have I Been Pwned and Pwned Passwords, which is why I see this. But if you were saying, hey, look, latency is important and we're the sort of organization that can pay for it, this is awesome. So that's making it fast. Have a look at the chart too. It's a really, really cool chart. Plus, I've got a chart in here which they also generate, which is response time improvement by geography. If you're in Austria, you are winning out of this. Because you'll see there's a great big green dot. Munich. If you're in Germany, in Munich, that's where the big green dot is. And I actually went and did the maths. Munich is a 17,000 kilometer round trip from Seattle. So when we're seeing sort of hundreds of milliseconds of latency, that's because our data's got to go 17,000 kilometers, you know? What is it, about eight and a half there and then another 8.5 back. And then do the processing bit in the middle when it hits the server. So that's really cool. Another thing here is Brotli. And you know what? I'm going to test this now. So while I'm talking, I'm going to test it. So Brotli is another compression algorithm. So we normally think about HTTP compressed traffic using gzip. Gzip is fine, Brotli is better. Depending on your content type, Brotli can be massively more efficient. It's not turned on yet, but I'll explain why in a moment. Now, I link here to a post from Scott Helm where he was actually seeing a 33% reduction in the size of his HTML when, let me rephrase that. He was seeing a 33% reduction in the size of the actual compressed response for content of type HTML. For other content types, particularly if you're talking about highly compressed content types, so they're very efficiently compressed JPEGs, you're not going to see that. I've got Brotli enabled, which is something Cloudflare supports. Again, I think it's on the commercial plans. And what I was seeing is, say on the Pwned Passwords page, so if you go to Have I Been Pwned Passwords, response size when I was only accepting gzip was 8,139 bytes. Once I accepted Brotli as well, 7,520 bytes, which is about an 8% reduction. So it's not quite Scott's 33%, but it's like toggle this switch and get an 8% reduction in your traffic size. Which is cool because that still matters, particularly when bandwidth gets small. Because remember, this is the size of the content between Cloudflare's edge nodes and the clients. So if someone was, let's say they're using Have I Been Pwned on a mobile device and they've got a crap connection because they're Australian, this would actually make a difference. So that's cool, but I kind of made the point here that as of writing the blog post and having just checked, also as of today, Cloudflare hasn't enabled Brotli for text plain content types. It's meant to come on any moment now. You might even see it by the time you see this video. So I'll get the advantage of that. So they were the main things there. So that's what I've done in terms of trying to make Pwned Passwords super, super fast. And you can probably tell from my enthusiasm in explaining this is that I am actually really enjoying building this stuff. I mean, it's nice to see it so popular and have the good press and everything, but it is fun, and I honestly have a desire to, you know, like finish this recording and then go over here and actually build out some of the other stuff like the more efficient streaming coding and things like that. It's just good fun. It's nice having a project. Have I Been Pwned began because I wanted a fun project. And now here we are doing these things. One last thing, and I touched on this very briefly before. We can search Have I Been Pwned by range, first 5 characters of the hash. Search Pwned Passwords by range. We can also search by an entire hash. I'm seriously considering killing the latter. Now, there are a few reasons for this. Number one is that you don't get the privacy protections of searching via the entire hash range. You just don't get that privacy at all. Number two is that because searching by an entire hash has an enormous address space in terms of how many possible combinations we have, I don't get the same caching benefit. So, now we're saying you don't get privacy, which is not good for you or not good for your customers. I don't get the benefit of being able to cache things because before I had like 16 to the power of 5, now we've got 16 to the power of 40, which is a very, very large range of possible values. They're not going to cache as efficiently. The other thing is that the time is not as efficient. So I've actually got a real-time App Insights. And in case, folks, I've said App Insights twice now. In case it's a foreign term, this is Microsoft's sort of measurement and orchestration and sort of the new Relic implementation within Azure. But it's a Microsoft thing. So my App Insights are telling me that the range get is now running at, over the last 24 hours, it's run about 250,000 times, average duration of 60.6 milliseconds, so maybe 10% slower than the figures I gave yesterday. They do go up and down a little bit. Figures I gave yesterday, figures I gave when I was comparing the table and the blob stuff. So 60.6 for range, password get, where I'm literally taking the petition key and the row key and pulling one record out, is 106 milliseconds. So it's running, I don't know, like 40% plus slower than actually getting the entire thing. Not only that, but I'm looking at the count of these. So it's actually 244,000 executions of range get in the last 24 hours. It's 3,300 executions of the individual password get. So it's like 1.x% of the total executions are for getting an individual password. I have actually now put a little warning on the page of the API description for Pwned passwords. And I've said, look, I will likely deprecate pulling a password by individual hash. If you have a reason to use it, please let me know, because I would like to kill this, but I don't want to kill anyone's implementation. And I have a few ideas about how I can do this and gradually wean people off. If you're using it and there's a good reason for it, please let me know. Otherwise, do use the range search for all the reasons I just mentioned there. All right, so that's that. Next thing, because I'm conscious we're at 47 minutes already. I mentioned data breaches. 2,844 new data breaches. Now, this was one of these cases where I had to sort of think, is this data I want and have I been pwned? And let me quantify what I mean by that, qualify what I mean by that. There's a lot of data out there floating around. When there's a discrete data breach, so a website gets hacked, their data gets leaked, it's clearly from them. It's an easy decision. It goes into have I been pwned. When there is data I can't reliably attribute, it may have been amalgamated from different sources, may even be fake. That is a harder decision to make. And I've got to sort of say, do I load this in? And I may not have complete confidence in the authenticity. I do have a verified attribute, and I'd say very clearly whether I verified it or not. Is it actually going to provide value to people? Is it going to confuse them? Are people going to get upset? I have to make a call on this. And certainly I have seen large volumes of data in the past which just did not make sense to put in have I been pwned. There was news in December about this 1.4 billion records from the dark web. And I used that in my blog post about the dark web FUD stuff. There was no point putting that in have I been pwned because it came from things that are already in there. Because there was 99-point-something% of those records, I think it was a very high 90s%, that were already in have I been pwned, and I could trace back to the source breaches. Didn't make any sense to put that in there. It would have made nice headlines, it would have got good press, but it just felt dirty. It was the wrong thing to do. So that didn't go in. This data was different. So this was I don't know if notorious is the right word, a very well-known hacking website posted a link to this data, which was then sitting on a file sharing service where you could go and download all of this, almost 3,000 different incidents. And I approach this with the same sort of caution as I do whenever I see sensational claims about loads and loads of data having been leaked. But I sucked this down and I found that, first of all, there was a bunch of redundancy with data already in have I been pwned. So I talk about Dropbox, for example. There's a file called Dropbox, 18 million records in there. I think 18 million, a lot of millions. Every single email address I pulled out of that file that was called Dropbox and checked on have I been pwned came up with a hit against the Dropbox data breach. Very likely that it is email addresses from Dropbox. The interesting bit is they all had plain text passwords next to them. Now, Dropbox definitely didn't store passwords in plain text. They stored them in SHA-1, but the leak did not have the salt in it. So they were salted SHA-1. The leak didn't have the salt, which makes it enormously hard to go and crack stuff. They also stored them in bcrypt work factor 8. Crackable, but a very resilient algorithm. Incidentally, most of the breaches I see are a work factor 10, which would be, I believe, 4 times slower because they exponentially increase as the work factor increases. So the bcrypt stuff was unlikely to be cracked en masse because it's going to be very, very hard work. So I went through and I tested a few things, and what I found is that the vast majority of plain text passwords against Dropbox accounts, when I took the email address that that plain text sat next to, and I went to the source Dropbox data breach, pulled the email address that was found in the bcrypt hashes, checked the plain text in this new big set against the actual bcrypt hash in the original Dropbox. I hope you're still with me. I know this is getting confusing. Long story short is that there were several passwords from this new set which were the actual passwords from Dropbox, but most of them were not. Most of them I tested were not. I linked through here to an online bcrypt hash checker where you can put in the bcrypt hash, put in what you think the plain is, and then it will hash it with the appropriate salt in the hash, and then go see if it matches. So the bottom line was that I was very confident this wasn't actually passwords from Dropbox, but due to the prevalence of people reusing passwords, these were likely people's real passwords from other places, and it just so happens that they use them on Dropbox and elsewhere. Anyway, so that was starting to give me a bit of an idea of what was going on. I went through and trimmed out, I think it was 40-something files from this nearly 3,000 data set that were already in Have I Been Pwned. Later on, I realized I missed one, which was Plex. So I didn't take Plex out, and Plex is already in Have I Been Pwned. Their forum got popped a few years ago. I was in that one too. Thanks very much, guys. So I went through and sort of trimmed out all of the cruft, for want of a better term. Now, after I did that, and I went through and I actually checked, and I'll just make sure I get my numbers right here, and I checked how many of the email addresses in this almost 3,000 set were in Have I Been Pwned. From a sample set of about 10,000 of them, I found that only about 66% of them were in Have I Been Pwned. Now, compare that back to the point I just made about that 1.4 billion, where it was high 90s. You know, so basically just about everything was in there. And now we're saying, well, actually a third of this data is not in Have I Been Pwned. That is now a significant number because there are tens of millions of people who have never been in Have I Been Pwned before that are in this data. And of the 66%, even though they're in Have I Been Pwned, they could be in there for totally unrelated incidents. So bottom line is there was a huge amount of new data. So I loaded it. But the problem now is that if I load it, I can't tell people where it's actually come from. I mean, all I'm doing is I'm saying, take these almost 3,000 results, go and get all the unique email addresses out of them. There are 80 million unique email addresses. Put them in Have I Been Pwned and then tell people that they were in this big thing. And I did list every one of those 2,844 files so you can look at it and you can go, yeah, I can recognize this one or that one. I did have a bunch of people come back and split into that 90%, 9%, 1% bucket again, where a lot of people are like, you know, thanks for letting me know. I had a look. I figured out I'm probably from this side or that side. 9% going, look, it's a little bit hard because I would really like to know which one of the files I'm in. Now, I don't have a construct in Have I Been Pwned to do that because I've never had to before. Actually, I probably could have done that in one, maybe one other. If this becomes a theme, I have to think about it. But I don't have a construct to say, you were pwned, and then here is additional information about where you're pwned, because normally it's very simple. It's like, look, you're in the Dropbox data breach. You know, like that's all you need to know. It's a very Boolean response. So I appreciate that did actually make things a little bit hard on some people. And then 1% of people, I won't swear again in this podcast, but you know what they say. So this was a large set of data that interestingly enough, some of the responses I've had later on has been pretty much confirmed as well. So I had multiple companies that were in this data set reach out to me needing more information. And with my help, we've actually managed to go through and verify that in many cases, yes, this was legitimate data. it was from incidents a very long time ago. But the really curious thing is that there are so many sites listed here that will never even respond. And I won't even read them out here, but you can have a spin through and have a look at some of these names and go, these are little obscure things. One of them popped up and said, yes, this was from 15 years ago. You know? So I guess the sort of summary there is that there's a lot of data floating around. It's from different places. A lot of it is legitimate. It's certainly not verified. I can't tell you exactly which one it came from, but at least you've got a whole list there. And you can get a little bit of a sense of its data floating out there doing the rounds again. And frankly, like the actionable thing at the end of this is you go and get a password manager. You know, and it's really this becomes the actionable item out of just about everything you do on Have I Been Pwned. It's like, hey, I used Pwned passwords. I saw my password was in there. That's because you don't have a password manager, you're not creating good ones. Or my email address was in a breach, what should I do? Well, if you have a password manager and you have strong, unique passwords on everything, they're very unlikely to get cracked, so you're only screwed if they're in plain text, and your scope of risk is only that one site because you're not using it anywhere else. And I know people are curious and they want to know as much as they can. It's the same reason they keep asking me for the original source data so that they can see what their date of birth or their credit card number or whatever was. But look, again, this is the way it works at the moment. I hope it's useful enough for people to understand where their data is spreading. Okay. Boy, this is a big one. On to the next thing. And I almost feel a little bit guilty leaving this to the end because, frankly, I think it's probably the most important thing I've done in a very long time for multiple reasons. And I want to talk about government, and in particular, governments using Have I Been Pwned. Now, I only announced this a few hours ago, so I am only getting very, very early feedback. It was after the UK pretty much switched off for the day and many would have gone to bed, and it was very early for Australia, and I pretty much started recording this as Australia came online for business. So I'm really not sure how it's been received yet. I wrote a blog post today called "The UK and Australian governments are now monitoring their gov domains on Have I Been Pwned." And this is a really significant thing. And I want to explain how it works, how we got here, and what it does and doesn't include. So as of today, the Aussie government and the UK government have the ability to query any .gov.uk or .gov.au domain. So for example, if there's a library somewhere in a county in the UK, the NCSC, so the National Cybersecurity Centre in the UK, can do a domain search to see which aliases on that library's domain have been compromised. And the same sort of thing in Australia, whether it's a health service, whether it's any sort of other government service that runs on .gov.au, or a very small number of other whitelisted domains. So for example, the CSIRO in Australia, our scientific research organisation, that does not run on a .gov.au domain, but that's included in the whitelistable stuff that they can query. Now, I want to talk about how we got here. Governments are big organisations. They have a lot of departments. And what we actually found in Have I Been Pwned is that a lot of government departments were using the service. In fact, in the blog post I make mention there's a very significant portion of the Fortune 500 using the service as well. And the reason why I know this, when I say using the service, they're doing domain searches. The reason why I know this is they're subscribing to notifications. So they literally say, I want to go and verify that I own acmecore.com. I've done that. I've uploaded a TXT file. I've received an email to one of the addresses on the Whois record, etc. Now I've proven ownership. I want to get an email every time it appears in a breach. And of course, I have that information. That's how I know who to contact. So when we looked at the data, we saw a large number of departments in both countries in the government independently monitoring their domains. Now, I think this is actually very good because this is departments saying, this is important information. We want to know when this happens. You know, I want to know because I want to protect the people in the library, for example. And this, of course, would be the staff working there, the government employees. But they're all doing it independently. And they're all part of this one government, this one large entity. But they're doing all of these independent little domain searches. And then they're doing their own sort of processes of what do they do after they appear in a breach. And there's all these little silos. So when we started looking at this, we said, wouldn't it be good if we could take all of these things and unify them? And not just the ones that are there already doing domain searches, but all the other ones that have never done them before as well. So would it be good, let's say for the UK, if we could roll all that up and have one sort of central monitoring and reporting mechanism where the folks at the NCSC could say, hey, there's just been a new data breach, and in this data breach, we've seen 5,000 different aliases across .gov.uk domains impacted. We're going to communicate that with the folks who run, not just in the departments that were previously doing domain searches on their own, but also all the ones that never did it before. That's very powerful from a government perspective, because now they can look at it and say, we're starting to see things that could actually impact the security across the entire government. So that was sort of the original idea. And that's something that I worked on both with, as I said, NCSC in the UK and also ACSC in Australia, the Australian Computer Security Centre. I did get that acronym right, didn't I? ACSC. This has just been the most insane week. Australian Cyber Security Centre. How could I forget cyber? So, National Cyber Security Centre and Australian Cyber Security Centre. So in both these cases, they now have the ability to do that. Now, the reason why I'm talking about it is that there's a few different things here. So first of all, they're using services which I built for commercial subscribers to come and use. Now, I have written about this before, and I've always kind of walked this line of, I want to make it as transparent as possible how the service is being used. So I want people to know that there are companies out there that do pay for access to their data. And at the same time, I don't want this to be a promotional thing. So I don't, this is why you go to have I been pwned and there's no like buy now and flashing lights and go here and subscribe and pay this money. So there's got to sort of be this balance of transparency and making sure that Have I Been Pwned remains first and foremost a free service that people can use to do good things, and it's not just a money grab. This is not the intention at all, so I don't want people looking at it that way. So that commercial service has existed for some time. I linked through to one of my earlier blog posts, and there's lots of references I've made to it in the past as well. So the mechanics already existed for it. Now, I wanted to make sure that if they were going to use this, and they use it to do a combination of on-demand searches where they say, hey, let's search whatever.gov.au, and then they get notifications. There's like a webhook callback model where they get a request to their endpoint to say, hey, we just found these aliases on these domains that are within the scope of your overview. So I wanted to make sure all that got put in place, but I wanted to make sure that I wrote about this publicly so there was transparency about government use of the service. The last thing that I wanted is to not talk about this and then someone somewhere who was aware of the fact that the government was using it to somehow misconstrue this as being like some sneaky backdoor or something like that, because it is not that. All we're doing is we're taking all the free things that they used to do before that were spread out into all these little silos, and we're just rolling it all up into one big free thing. So this is using what I provide commercially to some companies, but the government gets it for free for all sorts of reasons that I mentioned in the blog post. Not least of which is that we really do kind of want governments to look after us. And I'm going to come back to that too, because there's a very important discussion to have there. So that's what they've got. That was announced only about 5 hours ago. I think I published that blog post. So again, very, very early days. The initial feedback I've seen via Twitter has been very positive, which is fantastic. I want to talk a bit about these two departments a bit as well, because I think we need to put in context what they sort of do, and also some of the perceptions people have about government. I did a talk in London around the middle of last year. I did a user group. I think it was the Skills Matter user group. It was massive. They had hundreds of people turn up. And at the end, someone asked me about governments. And effectively the question was, can we trust governments? Aren't they all out to get us because of the Snowden leaks and so on and so forth? And it's a really paradoxical sort of situation where most of what we hear about with governments and cybersecurity, for want of a better term, sorry about the cybers, most of what we hear about is when something bad happens. And a lot of bad stuff has happened. Let's be totally clear about this. What happened with these Snowden leaks and the things we learned about overreach were not cool in any way, shape or form. And they made big press, and rightly so. We don't hear about the good stuff. Rarely. It's almost like a tip of the iceberg, right? There's all this stuff that happens beneath there where governments are doing things to actually try and keep us safe. And we want this, right? Like, as much as we don't want unauthorized eavesdropping or backdooring of encryption and things like this, we do want to not get blown up, and we do want to keep our kids safe and all the rest of it. And I'm not trying to sort of trivialize that and be trite. I'm trying to make the point that government actually plays a really, really critical role, and it's increasingly important because we know that there are lots of nation-state style attacks against critical infrastructure and all the rest of it, and we know that this is sort of the I hate to use this term, but like the battlefield of the future, right? It's online. So we really, really need governments to do the right thing. Now, what tends to happen is we continually judge them on the negative side of stuff because that's what we see. That's what is in the press. And we miss all of the really cool stuff. And what I've found really interesting, not just as part of this initiative, but everything else I've done that has touched on government or law enforcement, stuff like the Congress thing last year as well. Every time I've met up with people in government, they have been awesome. Like, absolutely without exception. Just lovely people doing really hard jobs. They're working in the public sector, so they're often under-resourced. They're often earning a lot less money than what they could if they go out to private enterprise and cash in as well. But they're doing it because they genuinely want to make a difference. And they're doing genuinely really good things. So that was the answer I gave back in, I think it was June, in London. And that was sort of at the point where we started having these discussions about what we could do as well. So I'm really supportive of helping these guys do what they do because it's in everyone's best interest. Beyond that as well, we are actually seeing some pretty cool material created by these government agencies. So NCSC in particular has created some really good publicly facing material. So I'll give you a really good example of this. One of the bits that I often point people to is they wrote a piece about let them paste passwords. I think this was the entire title, where they said, hey, if you're building a website, you shouldn't stop people from pasting their passwords into it. You ever see a company do this? I'm often berating companies for this. It's like, well, we're stopping people from pasting passwords because security. I think they had a checkbox somewhere. And we know that that actually makes it hard because that can break password managers and other mechanisms that people have of actually elevating their security. So the NCSC has written stuff like that. They've created a bunch of guidance, not just for companies implementing security in their applications, but also everyday consumers as well. So these guys are doing a lot of publicly facing stuff in very positive ways. So that's what I'm doing with the government stuff. I'm really interested to see some of the comments that come back from this. I would love to know what people think is awesome about it. I'd love to know if people have concerns about it as well, or other ideas. But it was a very major thing for me, and we should see some comments publicly from the NCSC and ACSC as well. It was a major thing to have governments be comfortable saying publicly, we are using this service. Because at the end of the day, it is a service with billions of records that have been taken out of other people's systems. Nasty things have happened in order to make Have I Been Pwned viable. And I guess I'm just very happy to see government organisations happy to say, we're using the service in this way, and we're happy to be transparent about it as well. And I just think that's really cool, and I'm very, very happy with that outcome. Okay, last thing I'm going to talk about is my sponsor for this week. And I leave dramatic pause here for multiple reasons. Number one, it was an epic week for them to be sponsoring because it's one of the biggest weeks I've had on my blog because of all the things that I've just said. So DigiCert, good result, good week to choose. DigiCert has been in the news a bit this week. And fortunately, they have been in the news and looked pretty positive as a result of how they've handled this whole situation with Trustico. Now, I'm going to sort of avoid delving into the salacious side of what has happened with Trustico, but the long and the short of it is that they emailed off a bunch of private keys for certificates that they had issued from DigiCert, which they then made available to their customers, for reasons which are still not entirely clear. So DigiCert has mentioned some, or rather Trustico has mentioned some odd things to do with the fact that obviously Symantec is being distrusted by browsers, Symantec certificates. Symantec's actually sold their CA business to DigiCert. So all of that has changed quite dramatically. And I don't want to speculate too much around why Trustico has actually said there was like key compromise and we need to revoke all these things and send them to DigiCert. Have a read of some of the things I've retweeted today. I've actually got a series of quote tweets with like the scary ghost face. And the first one's got 1, and then the second one's got 2, and the third one's got 3. It just keeps getting worse and worse and worse for Trustico. They're not real happy with DigiCert, but DigiCert appears to have operated very, very transparently. They appear to have done precisely the right thing under their obligations as a CA. I think they've handled it really well. I'm not saying that just because they're this week's sponsor. They do actually look pretty positive when you go through and you actually read the chain of events just there. Trustico, I went to bed last night and their position was, we've done the right thing. You know, we're operating responsibly. I got up this morning. Someone's managed remote code execution on their servers. They've found XSS. Trustico's offline. Not looking real good for Trustico at all. Not quite sure how that will pan out. Incidentally, and I know we've been going for a long time now, last thing on this. I talked about the HTTPS naysayers last week, and I haven't looked, but I have a sneaking suspicion they're going to pop up and go, this is why you can't trust HTTPS. See, all these keys just got emailed around and everything distrusted, etc. Frankly, I think the outcomes of this show precisely the opposite, because this is absolutely blowing up. It's going nuts. It will almost certainly kill Trustico. I can't see how they can survive this. As soon as we see things like key compromise, CAs are held to such a high standard, and particularly the way DigiCert has responded and gone, your keys have been compromised, that's it, everyone out of the pool. You know, like revocation straight away. The way they've handled this is an indication of how seriously we do take incidents when there is any sort of compromise. And to me, if anything, what this is showing us is that as soon as there is an issue of this nature at all, bad stuff happens to the organisations that have not done the right thing very, very, very quickly. And frankly, I think that's a pretty good result, and it is a very, very clear lesson to other CAs as well. So I know that has been massively long. There has been a heap of stuff that's happened. I'm heading off to the US tomorrow morning. I'm going to be in Seattle all of next week at the Most Valuable Professional Summit, and then the Regional Director Summit with Microsoft as well. Then I'm going to be in Vegas the week after talking at the Episerver Ascend conference. And then I'm going to be in Seattle doing some Pluralsight stuff and visiting a whole bunch of different companies over there as well, doing tech things. And I'm going to share as much as I can as I get around the US and do that. Thank you very much for watching or listening to this absolutely epic one. I'm going to go and enjoy the last of what is now an Aussie autumn. No more summer. Going to go and enjoy that before I head off to the airport tomorrow. Thanks, everyone. See you later.